So here we are, page 2 of the wind reading guide, and at the top of the page there we start off with a couple of drawings, and they're asking us to label them land or sea breeze. So I want to explain land and sea breeze first before we just tell you the answer. So like we said in the previous video, during the day land heats up quicker, and so as that land heats, it starts to the air above it starts to rise, and that air rises because it has lower density, and when it has lower density it gets low pressure. Okay, and so having that low pressure then means that some air wants to come and rush in there and replace it. So during the day that warm air will rise, and as it rises up into the troposphere it's going to go out over the water, and during the day we know that the bodies of water are usually a little cooler, so the air is going to cool, become more dense, and it's going to start to sink. And now we said over here we created this area of low pressure, and this sinking air over here has created some high pressure, so the air here wants to rush over and replace the air that used to be over there. So if you are standing here on the shore, you're going to notice that wind is blowing from the body of water. And we name winds based on where they blow from. So because it's coming from the water, we say that this is a sea breeze. The contrary of a sea breeze is the land breeze, and this occurs at night. And so similarly, land heats up quicker than water, and it also cools off quicker than water. So as soon as the earth rotates far enough and the sun disappears from the sky, the land will quickly cool down. And because the land is cool, the air above the land will start to sink. And as it sinks, it is creating some high pressure. If you've ever gone swimming at night, you'll notice in the evening the water is still warm, so the air over the water is still rising. That rising air creates low pressure. So now you have this less dense air that's rising and leaving, and you have this high density cool air that's sinking. And similarly to the sea breeze, air will move from high to low pressure, and now the wind will be blowing from the land out to the sea, and so we call that a land breeze. So if we're looking at our reading guides, we want to name the breeze based on where the wind is coming from. So in this image here, the wind's coming from the sea, and at night the wind is coming from the land, thus land and sea breeze. So the land and the sea breeze are examples of local winds. So those happen in small areas, and they're based on unequal heating. Before you see a beautiful globe of the world. It's very simple, and it has labeled on it the equator. So the equator is the location on the earth that gets the most direct sunlight. So we imagine that the sun's over here shining, and the equator gets the most direct sunlight. Okay, and what then occurs is at the equator, air is constantly rising, okay, because it's heated and it's warm, so it rises. It then will go towards the poles, and as it goes towards the poles, it starts to cool off, and as it starts to cool off, it will sink and come back towards the poles. It will then get reheated, and the cycle continues. The same thing is happening all around the world. Air is heated at the equator, rises into the atmosphere, gets cold, and blows back towards the equator. So if we take a look at our reading guide, it says circle the letter of each sentence that's true about these global winds. Okay, these global winds are still caused by unequal heating of the Earth's surface. We get the most heat near the equator, and so we get this warmer air, and we have cooler air towards the poles. B, also, they produced by the movement of air between the equator and the poles, yes. C is not true. They do not blow in a straight line. You'll notice on this picture that they blow in this curved effect, and we'll tell you why in a little bit. That's caused by the Coriolis effect. The last one, D, is correct. They curve because of the Earth's rotation. Number 9 says, using the diagram, describe how the movements of hot air from the equator and cold air produce global wind patterns. So kind of like I showed you before, the most direct energy from the sun is coming here at the equator, and it's heating this air up so that it wants to rise. That air will then go towards the pole. It will then cool off and blow back down, and so you'll see here these arrows too are blowing back down. So they are caused by this unequal heating, which leads to unequal pressure, and so you will blow from areas of high pressure towards areas of low pressure. At the bottom of page 2, there is a double bubble and the difference between local and global winds. The similarity is they're both caused by unequal heating. The surface of the Earth is always heated unequally. The sun cannot cover the surface of the Earth equally. When we have that unequal heating, we get unequal pressures, and wind will blow from high pressure to low pressure. The biggest difference about global winds is that they blow in a constant direction, whereas a local wind, depending on the area of unequal heating, they can blow in a variety of directions.